All right, so let's say I ask you to design a circuit to take the average of three input voltages. So we want to take the average. So how do you compute the average of something? Well, we compute the average by adding up all of the numbers. So let's say that my list here is 1, 7, 9, and 12. I take the average by summing these and then dividing by the total number of elements, which in this case is 4. So that would be how I would compute the average here. So if I wanted to implement a circuit that does that, how would I go ahead and do that? Well, I can use my summer circuit. Let's go ahead. And so I said I want to take the average of 3 input voltages. So let's just go V1, V2, V3. And I'm going to need my resistors here. I'll pass that in, and then of course I'm going to have my feedback resistor. Ground my plus terminal input. And I'll call this R1, R2, and R3. And we know that we're going to have currents flowing through each of these. I1, I2, and I3. This I2 is looking pretty bad. Let me make it look a little bit better. I2. And then coming out, we know that we have IF, which is the same as this current. Obviously, we know we have 0 volts here, 0 volts here, and then this is my V out. And so what would I do here if I wanted to take the average of those three signals? I don't just want to add them. I want to take the average of them. And so what I would have to do is let me go ahead and recall how my KCL works at this node. I'm going to get I1 plus I2 plus I3 is going to be equal to IF, which in this case is going to be, my equation for I1 would be V1 over R1, V2 over R2, V3 over R3, and then my equation for IF is going to be 0 minus V out, so just negative V out over RF, right? And so if I were to go ahead and rearrange this, I get negative V out is equal to V1 plus V2 plus V3, R1, R2, R3, and then that whole thing is multiplied by RF. Well, let's say I just let my R1, R2, and R3 be equal, and I just call those values R. Let's say R1 equals R2 equals R3, which is R. Then I could factor that term out of all three of these, right? And so I could rewrite this as negative V out is equal to V1 plus V2 plus V3 times RF over R, right? And so I could sum my three signals, and then in order to take the average, I would just need to make this quotient here be equal to 1/3. So all I would need to do is pick RF and R such that that term equals 1/3. So maybe I pick 3K for R, and so maybe I pick R equals 3K and RF equals 1K. That would work like a averaging circuit. I would get negative V out is equal to V1 plus V2 plus V3 multiplied by 1/3, right? And so then if I wanted to get rid of the negative sign here and I wanted to make this a positive output, all I would have to do, exactly like I did in the previous example, is take this and pass it into an inverting amplifier circuit with a gain of -1. And how do I do that? I just need to ensure that this, I guess I'll call it R4 here and RF2, and this would be V out final. I would just need to ensure that R4 is equal to RF2. So maybe we just say that this guy's 1K and this guy's also 1K. And so then my final values for all the resistors would be, these would each be 3K, right? That's what we decided on. We decided RF is going to be 1K, and then we decided RF2 and RF4 would be 1K. And in this case, my Vout final would be negative of this, which is negative V1 plus V2 plus V3 all over 3. The negatives cancel, and I get Vout final to be V1 plus V2 plus V3, oops, over 3. All right, so we just designed a circuit that takes the average of 3 input signals. That's pretty cool. I think that's pretty awesome that you can do that with op amps. You can do all kinds of awesome stuff with op amps. So that'll end our op amp summing example. And in the next video, I am going to show you how to perform integration with an op amp, the op amp integrator, which is a really interesting, really unique and useful circuit for all kinds of applications in signal processing and mixed signal circuit design. But specifically, we're just going to sort of examine the operation of the op amp integrator, and then similarly, we're going to go ahead and do an op amp integrator example after that, like we've been doing. Okay, so I'm going to go ahead and end this video right here.